Okay, so we're going to talk about Unix time. But before we begin with that, we're going to have to address the 11-day issue. ChatGPT is right, but also wrong about this. So, here's the thing. So I said if you add an 11-day question at one point, you have to mirror it on the other side. I'll explain this in a real-world scenario, but here's what ChatGPT says. He says, that's a really insightful way of thinking. You're noticing that if a correction like the 11th day skip of 1752 was introduced at some point, I don't think you got that year right, ChatGPT. I think it's 1582. I don't know what it's referring to. I'm pretty sure it's 1582. Yeah, it's right here, 1582. So anyways, was introduced at some point in history, you might expect to mirror that offset backward for symmetry or continuity in a closed-loop timeline such as your Concordia model. No, it's just math. You gotta have it that way, because if you're gonna remove 11 days, you gotta add it to something else. You gotta use that same subtraction somewhere else so it balances on both sides. You gotta do it 1582 before and after. But here's the key distinction. Gregorian reform wasn't an abstract offset replaced to time. It's mathematical. This is looking at it from a perspective of a person looking at time. So you would never apply the 11-day correction, even though it would be a correction of itself. It was a real historical adjustment to fix cognitive drift that has already occurred in the Julian system. If you project a Gregorian calendar backward before 1582, it's already mathematically continuous. There's no need to mirror the 11th day jump. That's true, but it depends on how you understand it. And I'm going to show you this using Unix. The proleptic Gregorian calendar inherently preserves that correction through its leap year rule. So while your Concordian model could symbolically apply a mirror correction to keep symmetry between before and after in pure chronological astronomy, that would artificially distort earlier dates. It would distort the earlier dates, but you'll be able to see things that you would not otherwise see. You could see it as a symbolic change or a spiritual change, but it would still be there. It would be the behind the scenes that you do not see. I'll explain all this. No mirror correction, drift accumulates one way. Philosophically, Concordia symmetrically, applying a mirrored offset can make sense if your system treats 1582 as a temporal pivot point or balancing both sides of history. Right, you'd have to balance on both sides. You do one on one side, you gotta do the same thing to the other side. And it has to be tied to a significant event, which, of course, is what the Gregorian was based on. Or so they say. So, let's look at this from Unix time. What day does Unix time start on the Gregorian? And you will see this date on your computers. On other computers, you don't have if your clock died or whatever, you would most likely see this date. On any Unix system, at least. What day does Unix time start on the Gregorian? January 1st, 1970. That's the exact default moment from which all Unix timestamps. Alright. So they got this thing known as the Unix bug. It's called the year 2038, where on January 19th, I believe it's January 19th of 2038, all the clocks were reset to December 1st of 1901. Or is it? We'll go with it's either the 1st of December or the 12th day of December. I forget. But I can never remember these. I'm not really good at math. But it's not really a bug. It kind of is a bug because it counts seconds. Unix doesn't know months, days, years, or anything like that. Now it does have, I believe it has leap seconds, but that's because of the drift of calendars and all that. It has a count for daylight savings time and things like that. That's why you have that leap seconds. And then you run out of space, and then it has a reset. So we're going to look into this. So what are the seconds between a day, that bug day in seconds? The year 2038 bug moment occurs on 3/14/07, January 19th, 2038, on systems where Unix time is stored as a signed 32-bit integer. A signed 32-bit integer can represent that many seconds after the epoch. The epoch would be January 1st of 1970. So let's copy and paste this. Alright, so that's what you see. That's the day that you see. January 1st, 1970. When does the time roll back to? Because you get an overflow error. Wasn't thinking for a better answer. I don't understand ChatGPT-5 sometimes. I prefer 3 and 4. December 13th. Okay, so it wasn't the 1st and it wasn't the 12th. It was the 13th. At 20:45:52 UTC. That's what a signed 32-bit Unix time wraps to when it overflows from this many seconds. Wrapping back to... But here's the thing. Those seconds right there aren't... And you already see what I'm about to say here. And you see how it's 1 second off? Right, we're going to get into that. How many years is Unix time able to handle in seconds? It would be 68. It would be 68 years. Yeah, now it's adding them together, and I was about to do that, but it's 68 years. 68 years plus 68 is 136. So you don't just add the beginning, like the forward, you also got to do the negative as well. You got to have them equal out. So exactly the time between January 1st, 1970 to January 19th of 2038 is the same time frame between December 8th, December 13th, 1901 to January 1st, 1970. You just don't see that behind the scenes, but that's how it works. You gotta have them on both sides. You're just the middleman of what you see in 1970. And that's what I was saying about the Gregorian calendar. If you're gonna remove 11 days, you're gonna have to add 11 days somewhere else. Or actually, you'd have to subtract 11 days. It's a confusing system, but that's how they did it. If you're going to subtract over here, you're going to also have to subtract or add in the opposite direction. And that's what I was getting to. And that's why I used Unix. A 32-bit signed Unix timestamp can represent about 106 years total, roughly 68 years before and 68 years after 1970-01-01 epoch, January 1st, 1970. That's why the range, earliest, latest, it's the same day. And when you see me do this with the calculations, when I did January 1st, when I came up with the equation of the coordinate calendar, or the Chinese calendar, I used February 3rd to April 14th, and then I used January 1st to April 14th. Let's confirm that. April 14th, 2030. Then we're going to do February 3rd to April 14th, 2030. So January 1st is 104 days, 103 days. February 3rd to April 14th to 2030 should be 33 days, or 30. Wait, no. Oh, wait. Doing this wrong. That's adding them together. How did I do this? February 3rd. Oh, I remember now. So February 3rd to April 14th, 2030 is 70 days. That's how you get to 70 days on the Concordia calendar. Well, it's 71 days because it says it's exclusive of the start date. Again, depends on how you do the math. That would be January 1st to February 3rd. And because we're not going through a leap year or leap days or anything like that, we don't have to put in 2030. It would be the same in 2030 and any other year. And that should be 33 days. 32 days. Is 34 days. So when you take the 71, so when you minus the 70 days, 71 days by 1, then you got to do the same thing on the opposite side, which would be 33 days. And when you do that, of course, you get 103. Plus 33 equals 103. It already did the math for me because that's what math does. Yeah. So that's how you get 103 days. And it's based on the Chinese calendar, but you could use that for anything. You could use April 1st to January 1st on the Gregorian. Well, that's if you confirm the day. Or you could do what other equation could you do for that? That has to be based on another date before April 14th. I mean after April 14th. We use the Hebrew calendar, and that's how we would get the same 262 days. I mean, it works, even though that's Rosh Hashanah in 2029, which would be a year before, but still, it will come to the same thing. You just gotta have the same equal. You gotta balance the math out. So yeah, I wish I could explain it better, but I don't really know math that well. But I think you guys understand what I'm saying. So, yeah. So that's how you get the April 3rd. Like, maybe in a symbolic way, you get April 3rd, but it confirms what people have said, that it would coincide with April 3rd of that. And it coincides with 27th Nisan. So you would either have to, and they do tie together, Julian 16, and I don't have it on here, but I think it was Julian 16 and April 16th, and Gregorian April 14th, which would also be Nisan, 27 Nisan. 27 Nisan, you can't adjust the 11 day together through the Concordia or any of that, or you get 11 days off, and it wouldn't align. But if you did that to the Gregorian itself, then you would get. Actually, let me try something here. Since that's on my mind right now, I'm going to turn on terminal. Let's do that math right here. I'm going to put G. I'm interested. We should be able to do this. Alright, 0414. Now we're going to do minus 11 days. Now Concordia just uses days. So, it'll be a day offset. So we're going to remove 11 days from here. And when we remove those 11 days, we get April 3rd, 33 AD, April 5th, 33 Julian, and the 16 Asan, which coincides in 2030. We already saw this was April 14th of 2030, right? So yeah, you have to account for these 11 days offset, and we just proved that right here. Exactly what I said. What, and we can confirm this. Let's confirm this. We're going to go to ChatGPT, say, what day is in 2030? It would be April 14th in 2030. Oh, wait. Not the 7th. I just confused it. It's including 3,793. I'm reading Safari here for something. Yeah. That, we got it in that calculation. It's not what day is. Remove the year in 2030. That's a much easier equation for ChatGPT. The sun falls on Sunday, April 20th. Isn't that? Hang on, what day is that? That is between Easter and Good Friday. Wait, hang on. How is that Sunday, April 20th, 2030, if Easter Sunday is on April 21st, which is on a Monday? No, this doesn't make sense. I'm reading the AI overview of Google and the math doesn't add up. That doesn't make sense. Is that okay? Sunday, April 20th, 21st. Easter Sunday is on April 21st, which is on a Sunday. Oh, okay, I get it. Not really. How can you have April 20th and April 21st on the same Sunday? That's not possible. You're telling me two different things right here. That's not correct. That is way. That's not right. It's the eve of Easter, but yeah. But also, 2 days before that would be the 14th day, 14th month. It's all about in the calculations. It all aligns. It's just how you see it. And ChatGPT doesn't really have perspective or perception of that. I still don't understand how it's saying Sunday, April 20th is on a Sunday and April 21st, 2030 is on a Sunday. That would be Monday. I don't know. What day is April 20th? Unless there's 2 Sundays in 2030. So I Googled it. April 20th is a Saturday. So Easter, Palm Sunday, and all of them align to the same day. That's what we have demonstrated here. I don't know, maybe it's trying to tell me something here, but it's telling me it's Easter. I know that, but it's just a convoluted way of saying it. But anyways, this video has gone on long enough. It's been 20 minutes, and I just wanted to talk about all that. So, you leave a comment section what you think about all this. I would be interested in sharing these scripts of the Concordia so people can have access to all this. No, I do have ChatGPT write it for me because I don't know all the fancy calculations and all that, but of the Gregorian and the Hebrew and the Julian. So it does all that. I can do the Concordia, even the Concordia days, aligning them to all the things and getting all the coordinates right. That's difficult. But I can understand that Concordia days are like Unix seconds. And that's what I was trying to get to. So I hope you enjoyed this video, and I'll see you guys in the next one. Bye for now.